when redesigning the inside, are you going to be doing what's called the glass cockpit, or do you have a new design that you're looking to implement there?
Sure. What we're doing is we've completely redesigned not only the inside, but the materials. It's an all-composite vehicle, which is using the most modern materials that we can right now. It's got a new thermal protection system. It's got many of the things that have been advanced over the last 35 years since the shuttle was originally designed. Amongst those things that we're doing is that we have taken it was a 10-person vehicle. We now have a 7-crew vehicle, but we've added propulsion on board. So we're using our hybrid rocket technology, which we've been developing for a lot of years, to put engines on board the vehicle, which allows us to have our own abort capability. We don't need a separate vehicle to help us abort off the pad. It also allows us to have the ability to fly, and essentially fly the vehicle, we call cross range, that allows us to find alternative airports to land in if we have a problem, which means that we can go all the way to orbit without having an abort issue. We can find a runway to land on. And the vehicle can land on a 10,000-foot runway, which is any major commercial airport, which is a great thing. And what we're doing inside is to create a reconfigurable cabin. It's a little bit like a really big SUV in that you can put the seats down, you can take the seats out, you can get more cargo, you can put more people in it. And much like other airplane designs, Boeing with the 747 and Lockheed with the C-130, it's a reconfigurable plane that allows you to have one airframe that can do many things. We can be all crew, we can be all cargo, we can fly autonomously, we can do service missions using the same basic vehicle. And in doing that, we've created electronics which are the most modern that we have, that is not new technology, in that we're not trying to develop things that haven't been developed, but we're using existing systems from other types of air vehicles that really are quite well heritage for what we need to accomplish.
Now, hypothetically speaking, if something were to go wrong on orbit, would EVAs be possible from the hatch, or is that capability not included?
Well, one of the things you want to ask is EVA as to where. So yes, the vehicle actually, and I'll take the question a different way. We are designing the vehicle with the potential to do EVAs, and the idea for that is that we think we can be a servicing vehicle. Like the shuttle was able to service the Hubble telescope, when now that the shuttle is retired, there really is no LEO servicing vehicle. So using a combination of potential unpressurized or a pressurized cabin with an unpressurized capability, an EVA capability, and maybe even a robotic arm capability on the vehicle, we should be able to do servicing missions. So the answer is we are going to look to be able to do EVAs. In an emergency, there are 2 hatches on the vehicle. There's a rear hatch and there's a dorsal fin or upper hatch. So there are 2 exit points from the vehicle that one can leave from, and it's likely that the crew is going to have some type of suit capability as well.
When operations do begin, and I understand that you have several different test milestones. I understand that the first full mock-up drop test is going to be occurring next year. Is that right?
Well, it's actually not a mock-up. We have flown a scaled version of the vehicle at the end of December last year. We flew it at Mojave, and it was a really great project because we did it in partnership with a group of graduate students from the University of Colorado. And we built a good-sized version of the vehicle and drop tested it and flew it a few times and got a lot of good data from it. We have been working with NASA now for 2 years on the Commercial Crew Program. There was a phase 1, which we had 4 milestones in, and there's now a phase 2, which initially we had 9 milestones in. We've completed 4 in the first round and now 5 in the second round, so we're well into the program. It's on schedule, it's on budget. Recently, NASA has decided to exercise some optional milestones for us, which will lead us to do the first flight of the full-size, full production vehicle, and that's scheduled to happen in summer of 2012. That's called an ALT, or Approach and Landing Test. And it has historical significance because that is actually the same, it's almost the same identical test that the shuttle did on its first flight.
So how long do you think after that the first crew test flights might take place?
We are Well, we will be drop testing it with crew very shortly thereafter. The first flight will be autonomous, but then the subsequent flights will have a crew and a pilot on it. So we're actually going to fly it and fly it in. These are atmospheric tests, they're not orbital tests. In the following year, in 2013, we'll be conducting suborbital flights of the vehicle to test its speed and its endurance. And then in the end of 2014 and the beginning of 2015, so basically 3 years from now, we'll be conducting our first orbital tests and orbital flights.
How will the suborbital flights take place? What will be the launch vehicle?
We're still looking at that, and that's something that's an internal discussion with the company, but we have a couple of different options. We haven't made a public decision on that yet.